Everyone. We're going to do some problems that use the skill of dimensional analysis, sometimes called unit analysis. This is probably one of the most important skills to have. We're going to use it so much this semester. I use it in my research every day, and I would say I even use it in my daily life. So we're going to need conversion factors when we do dimensional analysis. And these are the conversion factors that will always be given to you. I'm sure you're familiar with some. Maybe you know the relationship between kilometers and miles already, or maybe between pounds and grams. But even if you don't worry about it. All of this will be given to you on tests. I'm going to give you your own copy of this in class, and I want you to bring it to every class because you may need it for a pop quiz. Notice that your temperature conversion formulas are here. We probably won't use pressure that much, and I don't even think we're going to be using energy that much this semester. We're going to live in the world of length, mass, and volume this semester. So let's try a couple. So they want to know, if I have 125 kilometers, how many miles is that? So before we look up the conversion factor that we need, let's think about how we would set this up. We have 125 kilometers. We need to multiply by a conversion factor such that kilometers is downstairs, miles is downstairs, and kilometers cancel out, and we end up with units of miles. So what was the relationship between kilometers and miles? Here it is. You can use either this one, or if you wanted to, you could use this one. I've already circled that. That's the one I'm going to use. So 1 kilometer equals 0.62137 miles. Anytime you use a conversion factor, when you write this ratio this way, you are saying that 1 kilometer equals 0.62137 miles. It's always a good idea to make sure that that's true. But I think we can finish the problem. I think our answer is going to have 3 sig figs. We've got 5 sig figs here. So yes, I think our answer should only have 3 sig figs. Let me do the arithmetic. And I got 77.67125 miles. But if I only want 3 sig figs, I would call that 77.7 miles. So let's do another fairly simple one. This time we're given miles and asked to convert to kilometers. So I would begin by saying, well, I have 502 miles. Now I'm going to set up the conversion factor such that miles are downstairs and kilometers are upstairs. Again, that means miles are going to cancel, and I'll end up with units of kilometers. Here I've got my conversion factor. For every 1 kilometer, there are 0.62137 miles. And let's do the arithmetic. Again, I think we're going to have 3 sig figs in our answer. And I got 807.8922381 kilometers, but if I only need 3 sig figs, I would call that 808 kilometers. And it's always a good idea after you do a problem to kind of reflect and make sure your numbers are reasonable. And I think that's right. If we look up here, we're saying that a kilometer is about half a mile, and our final answer is about half of the initial kilometers. And, it's always a good idea to do that. So again, if a kilometer is half a mile and we have 502 miles, wouldn't we expect the number of kilometers to be roughly twice that? And that's what we got, 808 kilometers. Let's do a few more. So now all of these conversions involve the metric system. Hopefully you've committed these prefixes to memory by now, because you're not going to be able to use these on exams. But here we're starting with kilograms, and we're asked to convert to grams, and the grams again would be the base unit. So we want kilograms downstairs, grams upstairs. Again, that's so kilograms cancel, and we end up with the units of grams. So do you remember what this prefix means? Well, 1 kilogram means that I have 1,000 grams. Kilo means 1,000. This relationship is exact. It will never limit you. So you've got to look here. We've got 2 sig figs, so we better have 2 sig figs in our answer. Basically, we're multiplying by 1,000. So just move the decimal point 3 places to the right, and you get 77 grams, which does have 2 sig figs. Let's see if we can do this one, converting from nanograms to kilograms. So this one's a little bit tougher, at least it is for me. When I wouldn't be able to go directly from nanograms to kilograms. I would have to go from nanograms to the base unit, grams, and then I would convert that base unit grams into kilograms. So again, how do you see this prefix as nano? Do you see it as 1 nanogram is equal to 1 times 10 to the negative 9th grams? Or are you more like me, and do you see it like this? Do you see it as 1 gram contains 1 times 10 to the 9th nanograms? However you want to set up the problem is fine. Do it in whatever way that makes more sense to you. But then to finish off the problem, you'll have to say that 1 kilogram contains 1,000 grams, regardless of how you define nano. 1 kilogram contains 1,000 grams. And I think all of our units are going to cancel. And then however you want to do the arithmetic, you should get the same answer in both methods. I'll solve it using this way on top, and then I'll compare it to what I get on the bottom. Okay, I got 1.45 times 10 to the negative 11th kilograms. And let me see if I get the same thing when I use this definition. Yep, same thing. 1.45 times 10 to the negative 11th kilograms. Again, we had 3 sig figs in our starting number. The rest of these conversions are exact. They won't limit you. And this is our final answer, however you want to do it. And I think it makes sense that we would get such a small value because nanograms are very small. So I hope you try these conversions on your own. We're going to do a lot more in class. Thanks for listening.